In this video, I'm going to show you a really cool trick in the Vectric software. idcwoodcraft.com. Hello, my CNC brother or sister. I'm Garrett with IDC Woodcraft, the company that provides you with the CNC router bits to carve out your amazing CNC projects. I'm going to show you an interesting trick in the Vectric software that sometimes it's just one of these things, once you get used to the software, you can start to say, oh, maybe I can do this or do that. And this comes from our CNC brother, Jerry, who makes bee boxes. And on his bee boxes, he has to cut handles just like you see here. So he cuts his handles on his CNC router. Now the problem that Jerry faces is the cut for each handle takes about 30 minutes. And it's because of the type of toolpath that he is using to do that. When I saw that, I said, Jerry, we can knock this down to 3 to 5 minutes really quickly. It just takes one of these things where you get to know the software really well. So this is going to be a little trick to kind of up-level you in thinking about how to design different things in your software. So first of all, I'm going to show you what Jerry set up in his Vectric software to make the handles, and then I'm going to show you how we redid it so it runs a lot better and a lot faster. So we're going to get into his design, and we're going to talk about something called fluting, which is a specific type of toolpath, something that's very cool, and I'm going to walk you through the fluting toolpath so you understand it at a bit of a level, because you will want to use it. But then I'll show you how I would redo it and how we did redo it and cut his time way down. So we're now in the Vectric software. I am using Vectric version 12, and this is Jerry's design. So you can see this is kind of the half orange shape, and this, when you carve it, we'll just run that out real quick. Let's preview the toolpath and preview all toolpaths. And this is what his project is and what it ends up looking like. It's a very simple type of cut. Now, he's using something called a fluting toolpath. And the fluting toolpath is great to use, but it wasn't going to work very well in this particular project. So I'm going to show you what the fluting toolpath is, and then we are going to get into the better way to do this. So when we go over to the 2D view, let's turn some things off here. There we go. And when we zoom into it, you can see a whole bunch of radial lines. So the project has all these vectors that go all the way around this project. And what it does basically is his router bit is cutting along every one of these vectors. I'm going to show you exactly what his router bit is doing. I've got to turn something off here. There we go. And we're going to go to the preview toolpaths again. And I'm going to use this slider right here. Now I'm going to just bring it down a little bit, maybe about halfway. We're going to reset the preview. I'm going to select the fluting toolpath. I'm going to make it visible. So we're going to click the checkbox here. And you can see there's a lot of toolpaths in there. When we get really close to it, the router bit is just making so many different moves in this. Now I want to show you what this is going to do. We're going to preview the toolpath. And now you can see that router bit is following every one of those lines. It does kind of a cool thing. It does that little cup shape, but you can see how it is just moving around this entire project and is cutting each line, just shaving a little bit off at a time. And it's starting from the upper middle of the handle right in here. And just a lot of moves on the bit. Now we're going to take a look at the time that this takes. So I'm going to close this preview toolpath, and we're going to look at the clock here. We're going to click the summary of all toolpaths, and when we look at the time, that says 22 minutes just to cut that little handle. Now Jerry makes bee boxes over and over again. That 22-minute run is way too long for someone who produces this kind of stuff. So I'm going to show you a little bit about this fluting toolpath and why this type of cut is like this. Then I'm going to show you the quick fix that's going to cut this down to 5 minutes. We're going to close that, and I am going to go to the 2D view, and we're going to zoom out. Now I'm going to get rid of this little box he has here, and you can see right there, there is a line that I drew, because I want to show you what a fluting toolpath is. So we are going to go over to this particular toolpath icon right here. When you hover over it, it says Fluting Toolpath. Select that, and we're going to select the vector, just the line. First of all, we have to set our start depth, and that is at 0. Our flute depth will be 0.5 or half of an inch. I'm going to use a 1/4 inch Ballnose end mill. Now, there's 3 different flute types we can use. We can use a ramp over complete length, so over the entire length of that line, it's going to ramp in. The next one is we can ramp at start and probably ramp at a distance. And then the last one is we can ramp in and ramp out. And then down below that is the ramp type. There's a linear or straight ramp, and then there's a smooth ramp. So let's fiddle with these 3 up here. I just want to show you real quick because this is definitely something you want to learn how to use, especially if you're making something like a soap dish or something where the water needs to drain off. So we're going to use a linear ramp. And what a linear ramp in a fluting toolpath is, it's basically a cut, and that cut is going to go in at a ramp. So we're going to calculate that toolpath, and we're going to swing this around over here, and I just want to turn off his toolpath. And you can see, let's turn that material off. We're just going to use a wire frame for the material. There we go. And you can see how the router bit is going to go. Now what this router bit is going to do, it looks like it's going to wrap it over to here and then come back. Let's see what it does. I'm going to slow it way down, and we are going to preview the visible toolpath. Now you see this one is checked. That means it's a visible toolpath. We're not going to preview this toolpath here. And let's preview that toolpath. And okay, so the router bit is going to start over here, and it's going in and out and making a cut. So we're going to turn the material back on, and you can see what it's doing. I'm going to reset the preview and preview visible toolpath. Oops, it has to be selected. And so the router bit comes in here. So it started on the opposite end. I'm not sure why I did that. But anyway, that is a flute toolpath. So that is the one that just ramps straight in. Now we're going to go back into that toolpath, double click it, and we're going to go ramp at start. And we're going to set up our ramp distance. My line is probably, let's see how long that line is. It is about maybe 4 inches long. The way I could tell, I'm just quickly looking at the line, is by looking at the scale over here on the left. If we really want to know exactly how long that line is, then we can hit F11, and we can go to, I believe, where's that measure icon? I don't use it that much. So there is an icon, there it is, this is XY. We click that, and then we just simply select the top of the line and then the bottom of the line. Oops, there we go, top, okay. And our line is 4.2 inches long. So, okay, so we're going to close that. We're going to hit F12 to get back to the toolpath menu, and we're back in this fluting toolpath, and now we're going to use the ramp at start, and we can dictate the length of the ramp. So it is 2 inches. We can also say the percentage of the ramp as well, the percentage of the line. I'm just going to go 2 inches. We're going to calculate, and we're going to reset the preview and preview visible toolpaths. And now, I'm going to speed it up just a little bit. Now you can see the flute actually goes down like that. It ramps for 2 inches, then it goes straight out. Now, the one I like the best is the radiused one. But this is how the ramped flute works when you can set the distance. Now we're going to go back into that toolpath, and I'm going to ramp, let's see, yeah, I'm going to ramp at start and at end. And then we're going to set the ramp length to 1 inch. And what it's going to do, it's going to ramp down 1 inch, go all the way across, and at the last inch, it's going to ramp back up. So we're going to calculate that. And you can see in the toolpath lines, that's exactly what it's doing. So I'm going to turn that back on. We're going to reset the preview and preview visible toolpaths. And there is our fluting toolpath with a ramp on both sides. But now we can get the radius in it too. This is the one that I really like. So we're going to go back into that toolpath, and instead of linear, we're going to go to smooth. And that smooth is going to be dictated relative to the ramp length. So we're going to take the linear, or the ramp, the complete length, and we're going to leave it smooth, and I'm going to calculate it, and now we're going to reset the preview and preview the visible toolpath. And I'm going to orient this to the left so we can actually see what it looks like. So what this is, basically, you can see it is an arc that it created all the way through the project. Let's go back into this, and we're going to ramp at the start. We're going to use the second selection. We're going to dictate the length of it. We're going to go back to 2. And so what it's going to do, it's going to ramp at a radius for the length of 2 inches. Then it's going to flatten out and go the rest of the way. We're going to calculate, reset the preview, preview visible toolpaths, let that run through, and there you go. You get the nice little arc ramp right there, and then it goes straight. One more setting with the fluting toolpath, and then we are going to go into how to fix this project that Jerry has. Now we're going to ramp at start and end. Going to click that. I'm going to go 1 inch, and with this setting, it's going to ramp down in at an arc. It's going to go across, and it's going to ramp back out. We're going to set it for 1 inch, so it'll ramp in at the first inch, and at the last inch, it'll do that arc ramp back out. Calculate, reset preview, and preview visible toolpaths. So there you go. I hope that this little quick, I kind of bombshelled this one about the fluting toolpath, because this is really about how to fix this thing up. But if you learned something here, give me a thumbs up down below, that little thumbs up button right there, and maybe make a comment if you just learned about a little bit about the fluting toolpath, or even learned that even exists, and some of the ideas you're thinking about what kind of project you can use on it. Let me know. Put it down in the comments. So now let's take care of Jerry's project. Let's make this thing run a lot faster. First of all, I am going to delete this toolpath, and here's how you delete a toolpath. You can select it, and you know it's selected when it's got the gray highlight and it's bold, and just hit the delete button, and that toolpath is done. I'm going to reset the preview. We're going to close this, and now we're going to just bring this out. So this is set up for Jerry's, this is set up for Jerry's project, so it's a 48 by 48 size material. And I need to turn his toolpath back on, and there it is. And now we looked at that with the clock, and that is taking 22 minutes. Really, really long. So here is how I redid this using the stuff in the Vectric software. Now this can only be done in the VCarve software and the Aspire software, but it's definitely an interesting little technique. And here's what I did. So we're going to go back to the design area, and we're going to go to 2D view. And we're going to ignore Jerry's stuff here. We're going to make a handle. And the way we're going to make the handle is by using a 3D model that's in the software that comes with your Vectric software. And the way we get this model, it's going to be a dome-shaped model, is we go to Clip Art. There's a little tab all the way over to the left side. Select that. You'll see Clip Art and Design and Make. We want to click the Clip Art one. And this menu is going to open up. And we want to find the one that has domes. There we go. Domes is what we want. Click that, and we now come up with several domes. Now we're just going to grab this dome right here. This is the deep dome. I'm going to just hold it with my left mouse button and drag it out into the field. Now, Jerry said, oh, I need this to be at a specific size. So first of all, we're done with the dome, so we're going to go back to the design area. So we're going to come over to this tab and click the design tab. Now we're going to change the size of this dome to whatever we want. So we're going to scale it. And the way you do that is come over to transform objects, and it is going to be the second button from the left. It says set selected object size. And now we can set our width and our height. And he wants it 4 inches wide. We'll just come up with this. We'll just say 4 inches wide, but the height needs to be different. So it needs to be taller. So what I want to do is, you can see it's 4 inches high as well. So what's happening is, when I have this X and Y checked, it's locking the scale of the width and the height. When I uncheck that, now I can change the height to, we'll say 6. And now watch what happens with the dome shape here. I'm going to click it, apply, and now we've turned it into an elongated dome. Okay, so the handle, let's get a little bit closer to there. And it can probably be a little bit bigger. You know, we'll just upsize it. That's just one way you can change the size of it. So just showing you. Now, we only need half of this dome, but I wanted to split the screen side to side. So I'm going to use this split screen button right here, so we can see the dome shape. Now, if you look at that, that dome is actually sticking up. And what that means is that 3D model is going to be up like that. We need to invert it so it goes into the wood so we can make a handle. First, I'm going to set it up for the handle, because we're going to basically cut the dome in half using a special technique. And that technique is that we are going to come into the egg here, and we're going to click that. And in the VCarve version 12 and higher, you come down to the bottom where it says 3D Model Tools. With the dome selected, we are going to click this first icon to the left where it says Create Vector Boundary. When I do that, it's going to put a boundary around the whole model, like a vector. So I'm going to click that. We're going to zoom way in so we can actually see it. Click it, and you actually can't see it. It is right there. I'm going to click off the model. Now you can see the vector that it created. And it goes all the way around the dome. And to make the handle, I basically need to cut it in half. And here's how we do it. With the snaps turned on, these two buttons right here, they need to be like this light blue color. That means they're on. If they're off, they'll be gray, just like I turned this one off. Now I'm going to click it again. It's light blue. It's back on. We're going to get a line, polyline, straight line. And I'm going to come down, and I just want to find that midway point on this dome right there, which would be right where that cursor has changed. I'm going to click that, and it is now attached to that line. And we're going to come across, and you see, let's expand this a little bit. There we go. And you can see that dashed line. That means it's going horizontal. I'm going to swing back until that cursor changes into that target with the dashed line, and then click. Now we can hit escape to get out of line mode, and I am going to now cut away the vector above this line. So we're going to use the trim tool, the scissors, click that, and I want to make sure that this little checkbox is checked, because that will make sure that when we trim that away, the crossed line will rejoin with the lower line. So here we go. We're going to click that, and now we close that, and you can see what we've made. We basically made the handle shape on his thing. It can be any size we want, any orientation. I'm going to just double click all that, and we'll shrink that down to more of a rounded size. And go like that. So there we go. Now, we have to fiddle with the 3D model. We have to do some changes, because we got to turn it from like that to inverted or convex. So is that right? That's convex, concave. We got to make a concave. So here's where that little 3D modeling trick comes in. It's some tools in the Vectric software. We're going to split the screens again side to side, and I want to reorient this. And we're going to click on that model in the 3D screen and click on it again. And now you see all these little icons come up. Now the depth of his handle is 5/8 of an inch thick. The material he's using is 3/4 of an inch, and the depth of the handle is 5/8 of an inch thick. So there's 1/8 of an inch left of the material. So we're going to set the shape height, the overall shape height, by clicking this button right here. And you see when I'm hovering over it, the 1.689 shows up. When we click on this, now we can edit this number, and we're going to change it to 0.675 and hit enter. And now we just change the thickness of it as you can see right there. But we need to invert it, and that's where this little tool comes into play. We're going to click that, and this menu comes up. Now all we need to do is go from this selection right here to this selection right here. It's going to invert the 3D model. And that should have inverted. Let's try that one right there. There we go. I needed this one, because if I did it like this, it's not working. So we did it with the cup where it's empty. And now what we've done is we've inverted that. I'm going to click close. When we look at it from the side, you can see it's no longer a dome shape. The dome actually goes down and in. So with that, now we can create our new toolpath. And you're going to see how much faster this really is. And by the way, if you have some suggestions here, obviously put them down in the comments, give some tips and tricks that maybe I'm missing. And when we inverted that dome, the terminology you would use when you invert it, going from a solid to like an empty space. Okay, so we are now going to hit F12 to go to the toolpath menu. And we're going to expand the 2D view by clicking this little button right there. And I'm going to zoom into this. Now, we are going to use the 3D finishing toolpath. This guy right here. I don't need to rough it out. We're going to use this one because it doesn't really require roughing with the bit that we're going to be using. So 3D finishing toolpath. Select that, and we now need to select our router bit. So we're going to use the Ballnose end mill. And we're going to use the brand new Ballnose end mill that IDC Woodcraft came out with, the downcut Ballnose end mill. This bit you see right here, which is totally different for Ballnose bits, which generally leave tear out. And you can see here on this maze where it's cutting that there is literally zero tear out at the top of the project. That's why I came out with this bit, because Ballnose bits leave tear out, and tear out is a pain on projects. Tear out and chip out, that is. This bit I will put link down below in the description. The minute we released it, that thing just took off. So many people have ordered it. So you'll get a free marble maze file as well with instructions, and you always also get a 3/16 ball bearing with it, so you can make a marble maze. Got instructions, so don't worry, and the G code is with it too. All right, so we are now here. I got to select the Ballnose end mill. First of all, I want to get rid of this one, so we're going to hit remove and select the new one. We're going to come down to Ballnose end mills, and right here I've got the downcut Ballnose 1/4 inch. Select that and select. And now we have to set up our machining line boundary. Well, what we're going to use the selected vectors. We just created the vector, which is half the shape of that dome, and we're going to select that vector. So we're going to select the vector, and we need to make sure that this is checked. We don't really need to worry about boundary offset. That should be set to 0. And then I want to use raster, not offset. Offset will start right in the middle of it, and it won't cut well. It just won't look as well. So we're going to use the raster cut. And the raster will start at one part, and it'll just cut back and forth as it moves up. Now, before we actually finish that, I want to check the offset or the step over allowance on the Ballnose. So we go up to the edit button, and this menu will open up. We have a 7% step over. We'll go with that. I'm going to make it a 10% step over, because that's going to affect the time. We're going to click OK, and now we're just simply going to calculate this. What I would do is name it. We'll call it handle BD14. BD14 is the SKU number for the downcut Ballnose bit. We're going to click calculate, and let's take a look at this toolpath. Now, when we look at Jerry's toolpath, you can see there's many, many toolpaths. Here, we are literally going back and forth, back and forth. Now, I'm going to run this toolpath. We're going to turn his off. We're going to preview visible toolpaths. And we can see now how this is cutting. I'm going to turn that up a little bit. And because this is only taking a 10% step over, we can turn the feed rate way up on this bit. So I am going to stop this toolpath by clicking the little X. We're going to close that. We're going to click the clock. I want to see what the difference is. So his is currently taking 22 minutes. Ours is taking 9 minutes. That's still way too long. So we're going to shorten this up by increasing the speed on this and even the step over. Remember, this is a handle on a bee box, so the finish is not that critical. So we're going to go back into the handle, the tool path I just made. I'm going to go to edit for the bit, and I'm going to increase the step over to 15%. Generally with the Ballnose bits, you need low step overs because commonly they're used for 3D models, but if you have too much of a step over, you're going to get these little ridge lines. In this case, it's a bee box. It doesn't really matter. It's going to be outside. So we're changing that to 15%, and I'm going to change the speed to 150 inches per minute. Click OK, recalculate, and then reset the preview, and we're going to turn his off, and we're going to run mine, and there we go. As it runs out, I'm very curious how we adjusted the time on this. And we can let it run on out. I'm just going to stop it. Well, it's almost done. Okay, that's it. We're going to close that, take a look at the clock. We went from 9 minutes to 3 minutes by increasing that step over by 5% and increasing our feed rate, doubling our feed rate. The reason I could double the feed rate is because we're only shaving off 15% of the width of that router bit. So it's going to go really fast. We're going to go out to the CNC machine and run this out. All right, we are ready to go, and I have the Ballnose set up. I've been using this a lot. I've made a whole bunch of marble mazes for Christmas, so I got some pitch build up on the back of the blades there. So I'll have to clean that up. But let's see how fast this thing runs out. Here we go. This should go quite quick. All right, wound up. There we go. So that took about 2.5 minutes. I had actually turned the feed rate up to 200 inches per minute, and the finish is almost not noticeable with that, but that's still actually a pretty large handle. That was much faster than what Jerry had, and I had sent this to him, so he should be in good shape now. So I ran the bit at 15,000 RPM, 200 inches per minute, and the chips actually are really good for this. For this type of project, definitely good. Now you can see I screwed the board down, which is the best way you can hold a project down. This was run on the alt mill CNC router. Nice spindle, can handle this type of workload at that feed rate. I'm going to run one at 400 inches per minute. Same program, same settings. Let's see what happens. All right, here we go at 400 inches per minute. That was 1 minute and 30 seconds. And not much difference, a little bit rougher in there. Wow, this bit performs. So does this machine. I definitely recommend this machine. If you are looking for a CNC router, I've got a deep dive review on the Alt Mill CNC router. It's a 4x4 machine. Definitely recommend it. But I have to say, this really performed quite well. Much better than Jerry's. Make sure you drop by idcwoodcraft.com for your CNC router bits to carve out your amazing CNC projects. And I hope this video gave you a couple extra tips to carve out better projects, more interesting projects. If you got something out of this, like I asked before, give me a thumbs up. I know everybody asks for that. Comment down below. I want to comment because I'd love to see what you think about this, what you learned out of this video, and if you got some information, some tips for me and other people who are going to read the comments. With that, my CNC brother or sister, I hope you have an awesome CNC day, and I will see you in the next video. idcwoodcraft.com